So the other day I was in a classroom and we were talking about dividing by fractions, and we were having a discussion with multiple teachers talking about, I use keep, change, flip, and no, I don't use keep, change, flip anymore because that's just procedural. I use to divide, we multiply by the reciprocal. And I'm thinking to myself, I've actually said that many times, is we don't use keep, change, flip anymore. Instead, we should, to divide a fraction, multiply by its reciprocal. But the challenge with even that is that still procedural? And are we still building conceptual knowledge? Is it just some other memorized trick? And in math, we don't want to memorize tricks just to memorize tricks. We want to understand what's actually happening. What's the math behind the trick if we're going to use it? Because frankly, any procedure is a trick. It's really about not whether it's a trick or not. It's, do we understand why it works? To figure this all out, to make sense conceptually of why some of these rules work, I figure it might be helpful to kind of break down what we're looking at when we're thinking about fractions. Let's start with this. Let's start with 3/4 divided by 1/4. And to do that, I want to get as conceptual as I can. So whenever I want to really get conceptual, I want to think, can I possibly solve this with manipulatives or with tiles? And to do that, I'm going to think about this. So here's 1/4, 2/4, 3/4. And just to show like that missing fourth here, I've got 3/4. And again, just to kind of acknowledge what that looks like in a different way, I've got, so kind of thinking about it like 1/4. And that's 1/4, and that's 1/4, and really that's 1/4. I'm going to kind of put it over here because we're not really counting that one. And that's all out of 1 whole, thinking about that idea. So I've got 3/4 is kind of all out of that 1/4. So 3/4 divided by 1/4. 3/4 divided by 1/4 means how many 1/4 are in 3/4. Let's see, I've got 1 1/4, 2 1/4, 3 1/4. Oh, I've got 3/4. So 3/4 divided by 1/4 really just equals 3. If I'm taking 3/4 and dividing it into 1/4, I get 3. Okay, so let's take a look at this and see, okay, does that work with the algorithm or the keep, change, flip, or to divide by a fraction, multiply by its reciprocal? Let's take a look at that and just see if it works. Not really why it works, but if it works. So let's see, 3/4 times 4/1. So 3 times 4 equals 12. 4 times 1 equals 4. 12/4 really equals 3. Well, look at that. It actually is the same. They're the same value. They both equal 3 no matter how they do it. So I might just say that's cool, that's neat, see the trick works. But really what I'm trying to figure out now is, what's up with that 12? Where does that 12 come from? I don't see a 12 in here anywhere. And if I'm really trying to develop conceptual understanding, I really need to know what all the different parts mean. I can see that might have something to do with the force here, this 4, but that 12 I really don't understand. So what I'm going to do is I'm going to kind of dive in and see, okay, maybe there's other ways I can process this. Maybe if I do some other fractions, I can begin to make sense of what I'm looking at here and begin to make sense of what this looks like. So I'm going to go ahead and get rid of all this. We'll come back to it in a little bit. And I'm going to go to try another fraction, kind of see some other things going on here. And I'm going to try something here. In fact, sometimes it's helpful when I'm thinking about fractions to make things even easier and just take away the fractions. And I'm just going to go here. We'll think about like, how about like 8 divided by 2? And sometimes contextually, it could be helpful to think about, what are we talking about 8? So I'm thinking about, let's go into here. I'm going to make this contextual. I'm going to come into here and say, okay, let's say I have 8 pies. And I'm dividing, or I'm sharing with, let's see, with 2 people. Now, let me think about that. 8 pies shared with 2 people. That seems a little bit aggressive. So let's go ahead, because that's a lot of pies for each person. Let's go just change it, just change the context a little bit. So 8 pies shared with 2 groups. How about we do that? That seems a little more reasonable. So 8 pies shared with 2 groups. And really the question is, how many pies does each group get? So how many pies does each group get? Let's come over here and kind of think about that 8 pies. So let's talk about 8 pies. So here's like 1, 2, 3, 4, 5, 6, well, hold on, 7, 8. Maybe not organized, but there's my 8 pies looking at that piece and saying, okay, so here's my 8 pies shared with 2 groups. So if 8 pies are shared with 2 groups, I'm really kind of going into here. So 8 pies shared with 2 groups, it's going to be, let's see, it's going to be 4 pies per group, per whole group. And that's a way I could think about that. So 8 divided by 2. And just for the sake of it, let's just see if this works. So really, 8 divided by 2 would be like 8 divided by 2/1, and really 8/1. Okay, so then I'm coming over to here to say, okay, really that's 8/1 times 1/2. Just seeing, does that rule make sense? 8 times 1 is 8. 1 times 2 is 2. 8 divided by 2. So remember earlier I said I'm confused about that 12 that was in my other fraction. But in this case, I can see my 8. I can see here's my total 8. This number here is my 8. And that's going to be the total number of pies I started with. And I'm dividing it into 2 groups. So really, dividing 2 is the same as multiplying by 1/2. And that's, okay, that makes sense. But I want to go a little bit deeper because I still don't really understand everything I'm looking at with the other ideas. So let's go just a little bit different here and say, let's go with that same idea. So I'm going to say here 1/4 divided by 2. And again, contextually, what does that mean? 1/4 divided by 2. Let's stick with pies. Let's say I have 1/4 of a pie. And I'm going to share it with 2 groups. Now, these 2 groups are going to be a little more upset than the last 2 groups, because the last 2 groups started with 8 pies being shared with each other. But I'm talking about 1/4 of a pie shared with 2 groups. So let's see what that might look like. So how do I do 1/4 of a pie? So again, here's my pie. This time I don't have 8, I have 1/4. Okay, so I'm going to take that pie and I'm going to divide it into fourths. So here's my fourth. Oh, okay. So here's my 1/4 of a pie. And I'm going to share that with 2 groups. So that's the full amount I start with. I'm sharing between 2 groups. So really what I'm doing, I'm going to cut that right in half. And just for me to kind of make sense of that, I'm going to kind of think about, if I cut that in half, I want to cut them all in half. So I get that same size part. So when I'm looking at that, how much does each group get? Each group gets, let's see, there's going to be 1, 2, 3, 4, 5, 6, 7, 8. Each group gets 1 of those. 1/8. So I'm going to kind of talk about like 1/8 of a pie per whole group. Now, again, that group's going to be a little bit sad because the last group, they each got 4 pies. But in this, again, this scenario, this context, we're beginning to say, okay, what's happening here? So again, how do I make sense of that with the rule to divide by a fraction? We multiply by its reciprocal. Let's take a look into this and say, okay, so here would be 1/4 divided by 2/1, because that's a context we have in math. We know we can make a whole number into a fraction. So let's see, 1/4 times 1/2. And I multiply the numerator times the numerator, which is 1, and the 4 times 2 is the 8, which again is a rule. So multiplying numerator times numerator and denominator times denominator is a rule that we all agree is okay. Some of us don't really know why that happens. That's a whole different video. But as I look into this, I see 1/8, and again, I see that same 1/8 looking at this. And again, contextually trying to think about what does that mean in terms of the context of the pictures I'm looking at. Okay, so the one would be the 1 piece, and the 1/8 is the size piece. So each group gets 1 of those pieces, and it's 1/8 of an entire pie. So again, contextually, that makes sense. Okay, so I'm beginning to kind of make sense. Again, what I'm trying to get back to, if we don't remember, I'm trying to really get back to kind of what's happening over here, and where does that 12 come from? Why do I do keep, change, flip? Why do I to divide by a fraction multiplied by its reciprocal? I'm trying to make sense of this, and so far I'm seeing that it works. I'm still not quite sure why it works yet, though. So let's take it a step further and begin to do a fraction and a fraction. So now it's going to get a little more confusing to represent. So we're going to begin to think about this. Okay, I'm going to stick with my 1/4 pie. So I have 1/4 pie. This time I want to share it, or divide it amongst 1/2 of a group. And here's where it gets contextual as we're thinking about this. So if you're watching this and you want to pause it and think about how could I represent that, I challenge you to do that. I know most of us won't, but I challenge you to do that. Pause it here and say, how could I represent 1/4 of a pie shared with 1/2 of a group? What in fact does that mean? So we're going to get back to that pie. We're going to take a look at the pie here and say, here's my 1/4 of a pie. So here's my pie. Here's my 1/4 of a pie. Cool. So what does it mean? 1/4 pie shared with 1/2 of a group. So this is going to be the amount that 1/2 of the group gets. Well, if this is the amount that 1/2 of a group gets, then the other half of a group, if I was thinking about a whole group, would also get that same amount. So I'm going to kind of show that here. The other half of the group, so I've got the other half of the group over here on the other side of the room, also gets 1/4 if I'm thinking about the group as a whole. So again, that 1/4 of a pie shared with half of a group means that the total for the entire group would actually be this amount. And if I think about this, and I'm just looking at it, well, I know that's 1/4, and I know that's 1/4. So ultimately what we have there is we actually have 2/4 of a pi, or really half of a pi. So really it's going to end up being half of a pi per full group. And that's one way that I can understand this. There's a lot of other ways we can contextualize this, but thinking about, okay, what's happening here? 1/4 really divided by a half means something a little bit different here. So when I'm doing 1/4 divided by a half, we're coming into here, we're going to kind of see what does that look like. 1/4 divided by a half. So 1/4 divided by 1/2 can be rewritten with our rule as 1/4 times 2/1. And I'm going to pause there for a minute because I want to say, why does it make sense that to divide by a half, we multiply by 2? And I'm looking back at my picture, looking back at my context, and actually, I'm quite literally drawing 2 of them. I was dividing by a half, and in my context, to make sense of that, I ended up drawing 2 pi's, or 2/4 of a pi. So contextually, that does make sense. I got 1 times 2 is 2, and 4 times 1 is 4. So there's 2 slices of the fourths, which really can be condensed together to be 1/2 of the pi. So 1/2 of a pi per group. Okay, so actually that's beginning to make a little bit more sense about why I multiply by the reciprocal, because quite literally when we were picturing that idea up here, we were saying, hey, that's going to be something, I'm going to take that 1/4, I'm going to double it because I was only talking about a half a group. I'm trying to bring that whole group back. So that's really interesting as we're processing this, and I think we're getting closer to where I want to get to. So let's go back to that 3/4 divided by 1/4. So 3/4 divided by 1/4. And let's say, okay, how can I possibly represent that with my pi's? And here, again, I got my 3/4 of a pi, and I'm sharing that with, let's see, with 1/4 of a group. So 3/4 of a pi shared with 1/4 of a group. Okay, again, I'm going to challenge you. Pause it. See if you can represent that, although I know most won't, but I would challenge you to take a look at that. And if you do have those images, throw them in the comments. I love that too. But 3/4 of a pi shared with 1/4 of a group. So let's take a look at this. Here's my pi, and I'm going to shade in 3/4. So here's 1/4, 2/4, 3/4. Now I'm starting to get a little bit kind of, a little bit of over shading, so I'm just going to kind of just show us this, just to kind of remind us what we're looking at this. I'll kind of come in here and make it look a little prettier. So that's 3/4. And I'm sharing that with 1/4 of the group. So sharing that with 1/4 of the group, when I come into here, this is going to be like 1/4 of the group. So I'm thinking about the whole group all together. How many 1/4s are there? Well, there's going to be another 1/4 of the group over here, and another 1/4 of the group over here, and another 1/4 of the group over here. So when I'm beginning to think about this, okay, so each 1/4 of the group is going to get 3/4 of a pi. So I'm going to come into here and I'm going to say, okay, so here's this. Here's this. Sorry, they're not exactly the same size, but really we're thinking conceptually. So then we're coming into here, we're saying, okay, so let's shade in, here's 3/4. Here's 3/4. 1/4, 1/4, 1/4, 1/4, 1/4, 1/4. So I've got 3/4 of a pi is shared with 1/4 of a group. Therefore, the entire group, everyone combined when we're looking at it, gets all of this. So now I'm beginning to think about what's happening here and how can I kind of make sense of this. And by the way, the green is like the 1/4 of the group, and of the group, and of the group, and of the group, and of the group. So really what I'm looking at here is how much pi is here. Okay, so there's 3/4 of a pi here, there's 3/4 of a pi here, there's 3/4 of a pi here, and there's 3/4 of a pi here. So how many altogether? What's the whole combination of how much pi, I guess, we're looking at here? And thinking about this, I've got all those fourths. How many fourths? 3, 6, 9. So I've got 12/4 of a pi just kind of together. And hold on a minute. If I remember correctly, 12/4 of a pi, coming back over to my original page, 12/4 of a pi was right there. There's my 12/4. So I think I've kind of identified at least something about where that 12 came from. When I'm looking at it here and kind of processing this, I see 3/4, 3/4, 3/4, 3/4, and I get that 12/4. So really what that ends up being is 12 divided by 4, we know is 3, so that's 3 pi's. So 3/4 divided by 1/4, and again, wait, hold on a minute. We said that 3/4 divided by 1/4 is in fact 3. So 3/4 divided by 1/4 is 3 this way and this way. And when I draw it out with kind of some contextual pi's and looking at some of these pieces, so let's, again, coming back to here, going back to the same exact thing we saw earlier, is we saw, okay, we did this, we did 3/4 divided by 1/4, and we did 3/4 times 4/1. And again, I'm going to pause there just for a second, because why are we multiplying by 4/1? What's happening with that? We're multiplying by 4/1 because as we go into here, we see this is for 1/4. I want to find for the total amount. To get the total amount, up here we actually literally multiplied by 4, or added 4 times. So then again, I get that 12/4, and I get that 3. So why does that rule work? Here is why that rule works. That's something we're looking at, some of these processes. Now the next step, I'm going to go even a little bit further, because I feel pretty good about this, but I want to see, does it work with other more complex fractions? And we're going to do one more option here. We're going to take a look at this more complex and see, okay, does it work with 3/8 divided by 3/4? And what on earth does that mean? So again, we got that 3/8 divided by 3/4. It's always good to look at fractions and start with smaller fractions and fractions that make sense, and looking at that to get that contextual idea, because once we learn the rules and procedures based on contextual ideas, we can begin to say, okay, does that work with all fractions? So now again, let's stick with that same contextual idea. I've got 3/8 of a pi, and I'm sharing it with 3/4 of a group. And again, if you're playing along at home, I would challenge you, can you show a graphic of that? Can you show a model of this? And I've been sticking with pies. Of course, you could do it with tiles. You could do it with all sorts of different things. You could use the fraction tiles. But I want to see this 3/8 of a pi shared with 3/4 of a group. So I'm going to kind of go into here. I'm going to think about, what does 3/8 of a pi look like? So here's my pi. And I'm going to come into here and say that's 1/2, 1/4. Not quite yet 1/8. Now I'm at 1/8. So 3/8 of a pi. Okay. So let's see here. I've got this 1, 2, 3. 3/8 of a pi. And that is really the amount that 3/4 of the group gets. So 3/4 of the group gets this, which means there's another 1/4 of the group over here that gets this. I'm kind of thinking about this. So it's kind of like thinking about this. I got there. So there's like 3/4 and then one more 4, thinking of like a number line. So how much does that next 1/4, that 1/4 that for some reason wasn't part of this original part of the group? So if this is 3/4 of the group, what's 1/4 more? Well, I actually happen to notice that there's 3 pieces here. So really, if I'm sharing out with that group, one person gets this, one person gets this, one person gets this, or one amount of the group. So that extra 1/4 really is going to come into here and say, okay, that extra 1/4 really just gets kind of this piece here. They just get one more piece that is an 1/8. Looking at that, if I think of that contextually, I can say, okay, so here's 3/4 of the group gets this. So then the remaining 1/4 would just get one more piece. And if thinking about that, so then altogether, what is that? We end up finding out, okay, so that's going to be 1, 2, 3, 4. That's really 4/8, which comes down to being, looking at this, okay, I got 1/2 looking at this piece. So 3/8 divided by 3/4 contextually equals 1/2. Okay, how does that work with the actual, with the rule that we have, the procedures we have? So let's see what we get here. We're going to say, let's say 3/8 divided by 3/4 becomes 3/8 times 4/3. 3 times 4 is 12. 8 times 3 is 24. So now I'm, again, kind of in a pickle here, because I know that 12/24 is in fact 1/2. But I've been challenging myself to be contextual, trying to figure out, okay, what's the deal with all the numbers in the fractions? What's the deal with what we have here? So 12/24, I do see, it's great. I'm really happy, actually. They get the same amount, the same answer. But I'm not sure where the 12 and the 24 comes from. So I'm going to take a look and see, where might I see some things here? Where might I see some things here? And how could I be talking about 24ths? And if I'm thinking about talking 24ths, really to get 24ths with my context, I can come into here and say, well, there's 8ths here. And I know that 8 times 3 is 24. So if I actually broke each one of these up into thirds here, it's not perfectly drawn, but the idea of thirds. So each of those smaller pieces we're breaking into thirds now. So now I've got, really, it's not going to be 3/4. I mean, it is still 3/4, but it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/24. Thinking about some of these ideas, and then again, this one here is, break that one into thirds too. 10, 11, 12, 12 24. So if I actually divided all of those pieces, all of those pi pieces into thirds, then I can say, okay, I'm talking about 24ths. And in fact, if I look over here, now that I'm saying that, I'm thinking about that other rule that we learned in time and processing into here. Some of us learned that rule of, hey, if there's the same number in the numerator and denominator, they can kind of divide out. I might not know what that means, but dividing that out, I get to 1, and really dividing that out says, I no longer want to divide that pi piece into 3 parts. I just want to keep them as whole pieces. So we're kind of dividing that out, and that's, again, another deeper way we can look at it. But contextually, I could have either divided each piece into 24ths, or I guess the whole pi into 24ths, or I could divide the whole pi into 4ths, or I could divide the whole pi into 8ths. It depends on what I want to cut it up into, and that's kind of what we're talking about, some of those numerators and denominators. So really what I'm looking at is seeing all together from start to finish. I started here, and I started here with my pieces, if you remember, and I said, okay, let's take a look at these pieces with that placeholder over here, and we said, okay, 3/4 divided by 1/4, contextually we can see is 3, but then we have this other rule, which is either keep, change, flip, or it's going to be to multiply by a fraction, or to divide by a fraction, we multiply by its denominator. We have these different rules and these different procedures, which on their own are all procedural. Everything's procedural on its own, but when we're beginning to think about what does it actually mean, that's something we can process here too and say, okay, hey, this is beginning to make a little bit more sense of why this happens. And then some people might ask, why do I need to know this? Why can't I just memorize the rule? And one of the reasons for that is if you forget the rule, if you're not sure about the rule, do you have another way out? Do you have another way to process things? And frankly, I'm looking at this, looking at all the stuff we just did, when we started, this actually, with the tiles, may actually be the most efficient way to solve the problem. This may be the most efficient way. That took really 30 seconds, and I did it with 4 tiles. And I was able to divide 3/4 divided by 1/4 with that idea. And if you do want to stick around, I do have a bonus. There's a bonus fraction rule that we're looking at that nobody teaches you in school. And I do want to share this with you because it was shown to me a few years back, and I just thought it was absolutely amazing looking at some different pieces. And we can see there's a rule that somebody said doesn't work when in fact it does. And we're going to process into this. So again, if you're sticking around here, take a look at this rule. It's pretty interesting. I'm not going to get into why it works in this video, but I will show other videos too, just to kind of show that there's different ways we can deal with fractions. So here we go. Take a look at this. I got 3/4 divided by 1/4. Now, in math, they always told us in classes you to divide by a fraction, multiply by its reciprocal, or keep, change, flip, or all these fancy songs and things we have. What they didn't tell you is that you don't have to do any of that. What they didn't tell you is that you can actually divide straight across. Let's take a look and see. Does it work? 3 divided by 1. 3 divided by 1. Let's see. 3 divided by 1 and 4 divided by 4. Let's take a look, see if it works. What's 3 divided by 1 is 3, and 4 divided by 4 is 1, and that equals 3. And if I look over to here again to check and see, is that true? I'm looking over here, 3/4 times 4 over 1. 3 times 4 is 12. 4 times 1 is 4. 12/4 is 3. So we can divide straight across. We can do that. Or we can keep, change, flip, or multiply by its reciprocal. Does it work with other fractions? Let's see if it makes sense. Let's try another one here and see what we got. Let's try 3/8. I'll change the color actually so we can make it look a little prettier. So we got 3/8. We're going to go hit 3/8 divided by 3/4. Can I simply divide straight across? Is that allowed? Taking a look at this. So 3 divided by 3, well, no, that's 1. And 8 divided by 4 is in fact 2. So I'm done. Looks like that's correct. So let's take a look and see. So 3/8. Let's try the way that our teacher said we had to do it. So 4 over 3. 3 times 4 equals 12. 8 times 3 equals 24 equals 1/2. Well, look at that. We can, in fact, divide straight across, just like our teachers told us to do with multiplication. It actually does work, and that's interesting. So let's try and see, okay, does it work with all fractions? And let's get a little more complex, because these fractions, maybe he chose the fractions that work on those are the only ones that work. Try it with any fraction. And in fact, I'm going to try it with a really complex fraction right now. We're going to try one here. I'm going to do 6/15. And I'm going to divide that to 12/20. Divide by 12/20. I apologize. So 6/15 divided by 12/20. Let's take a look at this and see, okay, what is going to happen here if I actually just divide straight across. So we're going to go ahead here using that rule we just learned, and we're going to see, okay, what happens when I do this? And we're going to say, okay, what is 6 divided by 12? 6 divided by 12, I could think of as 6/12, or maybe I could think of as 1/2. Okay. So 6 divided by 12 is really 1/2, and 15 divided by 20. 15 divided by 20, 15 over 20, could end up being, well, you know what, I'll show it here. Some of us can't quite see that right now, and that's okay, 15/20. Good. And then I'm going to bring this down, and we're going to see, okay, as we're looking at this, what do we see? 15/20. 15/20 could be thought of, if I just take 15/20 as a fraction inside here in the denominator, 15/20 could be divide by 3, divide by 3. So I can end up over here with, let's see, I keep 1/2 on top, and we'll come into here, we'll keep this down into this piece and say 15/20. 15/20, 15 divided by 3, 20 divided by 3, we end up with 3/4. Oops, wrong color. So really that's where we got this complex fraction. Okay, so 1/2 divided by 3/4. So what's happening with 1/2 divided by 3/4? So another way that I can think of that 1/2 divided by 3/4 is I can process this and say, okay, 1/2 divided by 3/4. Well, 1/2 and 3/4. Just for the sake of looking at this, let's take a look and say 1/2 divided by 3/4. I can call this 2/4 divided by 3/4, just for the sake of kind of having them have the same denominator as we're looking through here and processing through this aspect. So when I'm looking at this, 2/4 divided by 3/4 is really very similar to just 2 over 4. So 2 over 3, because it's 2 of some kind of parts of the same size divided by 3 of some parts same size, it becomes 2 over 3. And when I look at this 2 over 3, that's going to be my answer. Let's see, did it work the other way? If I do multiply it out the same way that our teachers taught us to, so 6/15 times 20/12. 6 times 20 is 120. 15 times 12, let's see, 15 times 12 is 180. And 120 divided by, or over 180, if I divide both by, let's see, divide both by 60, I in fact get 2/3. So what we're talking about here is you actually can divide straight across, like we multiply straight across, multiply the numerator times the numerator, denominator times denominator. You can do the same thing with dividing. There might be a reason to do that. There might be a time that makes sense. In this particular time, that doesn't make as much sense because there's a lot going on here, complex fractions, but it does contextually work. There is a rule that works and processes works, so we can do different ideas. So really what I'm looking at here is going from using tiles to rules, to procedures, to memorized rules. There's different ways we can understand what is it we're expecting to do when what is it we need to do when we're dividing fractions. There's a lot of ways we can look at it. There's not just one right way. The key is, do we understand why it works? And if we get stuck, do we have a way around that? Do we have a solution path we can use for those different next steps?